Welcome students. Today we're going to cover 3.2 logarithmic functions and their graphs. So the first thing we need to do is define logarithmic functions, and before we do that, if you're having trouble on the homework, specifically the graphs, the issue was on delta math there's not a specific distinction between exponential and logarithmic, so I had to separate it out and have specific problems. And so if you weren't able to do it right, don't worry, it's still a completion grade. So nevertheless, we'll continue on. So a definition, a logarithmic function is for x is greater than 0. It cannot be equal to 0, it must be greater than. And a must be greater than 0, so both positive. Then, and if a is not equal to 1, then y equals the log of a of x if and only if x equals. So this means these two functions are inverses. The function given by f of x equals log base a of x is called the logarithmic function with base a. Okay, so we have common and natural logarithmic. Common is going to be, real quick, it's going to be log base 10 of x, and natural is going to be log, sorry, it's going to be log base e of x, sorry. And this is going to equal, ln of x. Okay, let's look at these problems. We're going to just work through them based on the definition. So our first problem is log base 2 of x, where x equals 32. And so we're going to just plug it in. Log base 2 of 32 is going to be, so this problem is, if you just use our definition, it will be 5. Or you can think of, well, we'll talk about this later. Log base 3 of 1 is also going to be 0. And log base 4 of 2 is the same thing as 1/2, the square root. So this is just the inverse of the exponent. So 2 to the 5 equals 32. 3 to the 0 equals 1. 4 to the 1/2 equals 2. And then log base 10 of 1 over 100 is going to equal -2, because 10 to the -2 equals 100, 1 over 100. So let's look at some of our properties. Let's just get a space in here. Okay, use a calculator to evaluate the given function f of x equals log of x. So this is going to be log base 10. So log base 10 is the same thing as log, okay, without any markings. So log of 10 is just going to equal 1. It's going to equal 1. Log base of 1/3 is going to equal, and this should be a fraction, a decimal, -0.47. 71213. Okay, it's not an 8. Okay, log base 10 of 2.5 is going to equal 0.3979 RO, and log-based of -2 is not is no solution, is error, because this must be greater than 0. Okay. Okay. So it won't have a solution, expect if it's a negative. Okay, so you have to take logarithms of positive numbers, or else you won't have a logarithm. Okay, log of base A of 1. Let's zoom in on this, and then we'll see where we are after we go through the properties. I'm hoping we get through the graph, but we'll see. Okay, so log-based A of 1 is going to give us 0. And it's because A to the 0 equals 1. Log-based A of A is going to give us 1 because A to the power of 1 equals A. Log-based A of A to the x is going to give us x because they're inverses. Okay, and then if log-base A of x equals log-base A of y, then x equals y. Okay? So, let's look at some of these. Let's simplify them. Log-base 4 of 1, that will just give us 0 because log-base A of 1 is always going to give us 0. Log-base 7, square root of 7, of square root of 7, it's going to give us 1 because it's the same. And log 6 to the log-base 6 is going to cancel, so all we're going to be left with is 20. Okay? This is going to lead into our one-to-one property, namely these three problems. So log base 3 of x equals log base 3 of 12. Now we cancel out the log base 3 because x, this is our one-to-one, x equals 12. So log, this is base 12, 10 of 2x plus 1 is going to equal log base 10 of 3x. Okay, the logs cancel, so you just have 2x plus 1 equals 3x. Solving this, we get x equals 1. Okay. And then finally, log base 4 of x squared minus 6 is going to equal log base 4 of 10. Solving this out, we get x squared minus 6 equals 10. So we get x squared minus 4 equals 0, x equals plus or minus 2. Now remember, it can't be a negative. We can never have a negative in here, so let's check. So if we plug in 2, if we get 2 squared, that equals 4. If we get negative 2 squared, that still equals 4. So 4 minus 6, does that work? Actually, sorry, no, that's why this doesn't work. It's 10 minus 10, it's minus 16. That makes so much more sense. Okay, then this is plus or minus 4. Okay, so plus or minus, that's why you check your mistakes. Plus or minus 4 is going to give us 16. Okay, 16 minus 6 is going to give us 10. Okay, so we do know this is correct. Okay, sometimes this squared will give us an answer that is not necessarily consistent, and that's a later question. Okay. Okay, we'll come back and work on graphing. Okay.